601 Newton cheetah runs with a force of 956 newtons. This cat runs from rest at 31.25 meters per second. How much distance did this run take? All right, so let's start by listing the givens so I can figure out what's going on here. So givens, list, a 601 Newton cheetah. All right, so what's going on here is this 601 is an adjective describing cheetah. So when it's an adjective like that, that's going to be the weight of the cheetah. So that's going to be our W right there. So the weight is equal to 601 newtons. And it runs with a force of 956 newtons. It runs from rest, so that's V naught is equal to 0, to 31.25, that's the final velocity, 31.25 meters per second. That's 70 miles per hour, by the way. How much distance did this take? So that's going to be my X. All right, so to begin with, I'm going to start by looking at the last part of the question. How much distance did this run take? So the only thing I have about distance I know about kinematics. So when I look at this from my typical kinematics equation, variables, I can see I have these three. I need one more, though, in order to solve something for x. But I can find it here with a force because I know F equals ma. But I don't have the mass to find the acceleration. But I know up here at the top, the weight, I know weight is equal to mg, which will give me the mass, which I can use in F equals ma, which I can finally use in the final equation. So let's see what this is like starting from the bottom and working my way back up. All right, I need an equation with V naught, V, A, and X in it. So that's going to be V squared equals V naught squared plus 2AX. Okay, so that's the kinematics part. But to do that, I got to find the acceleration from second law, Newton's second law. So that's F equals ma, and I'll solve that for A. But then I got to have the mass, because I keep going up. So the mass is going to be, oops, lost my pen there. The mass is going to be W is equal to mg. So in terms of solving this in the order that I'm going to do, what I'm going to do is I'm going to start from the bottom working up. That's the first step, second step, third step. All right. First step, find the mass. Find m. All right, what I know is weight is equal to mass times gravity. So the mass is equal to weight divided by gravity. So the mass is equal to the weight, 601 newtons, divided by 9.80 meters per second squared. So that's going to give me a mass, 571 point, bunch of decimals here, 5306122 kilograms. So I'll store that in my calculator somewhere so I can get all the decimal places out later when I need it. I'll usually store it under the variable m if I can, unless I have a calculator that just doesn't give me the alphanumerics, and I'll do what I can. Next step, I got to find the acceleration using F equals ma. So my next step, I'm going to find A, and I'm going to use F equals ma to do it, Newton's second law. So A, when I isolate the variable, is equal to force over mass. So the F, let's see, the A, I mean, acceleration is the force the cheetah exerts, not the weight, but the force it exerts. So that's 956 newtons, divided by the mass of the cheetah, which I just found out with all those decimal places, 571.5306122 kilograms. And when I do my calculation for the acceleration, for the acceleration, I get 1.672701,303 meters per second squared. It's supposed to be a squared there. Now I need to find how much distance the run took using kinematics. but I'm short on space, so in just a moment let me clear up some of the screen on the left. Ta-da! Okay, now I'll use kinematics to figure out what the distance is in that space that I just cleared out. So I'm going to use v squared equals v naught squared plus 2ax. Alright, now I'm looking for x, so let me isolate the x. 2ax is equal to final velocity squared minus the initial velocity squared. So x is equal to the final velocity squared minus initial velocity squared divided by 2a. So x is equal to final velocity squared, 31.25 meters per second squared, minus initial velocity squared, which is 0, that's easy. All that divided by 2 times a, so that's going to be 2 times this long number that I just calculated. 1.672701,303 meters per second squared. And that will give me my final distance equal to 31.32 meters, and to 3 sig figs, that'll be 31.3 meters.